Our 1.7 note is over inequalities, and this should be done without a calculator. Let's start with the first one. I have negative 4x plus 3 is less or equal than 15. This is a linear equation. Since it's a linear equation, I will just subtract 3 to get negative 4x is less or equal than, this time 15 minus 3 is 12, divided by negative 4, I will get x is greater or equal than negative 3. Just note that every time you divide or multiply by a negative number, you flip the inequality sign. So this is an inequality, so to write it as an interval, I need from negative 3 all the way till infinity, and that will be a bracket at negative 3. Let's look at problem number 2. Problem number 2 says 1/6 is less than negative 2x minus 13 over 12, which is less or equal than 2/3. I will first multiply everything by 12 to get 2 is less than negative 2x minus 13, which is less or equal than, if I multiply this by 12 as well, that will be 8. I will then add 13 to both sides. By adding 13 to both sides, I will end up with 15 less than negative 2x, which is less than 21. Then I will divide by negative 2. Dividing it by negative 2, we flip the inequality sign, both of them, and we will end up with negative 15 over 2 x and negative 21 over 2. This is an inequality, so write it as an interval. It will be from negative 21 over 2 all the way to negative 15 over 2. Parenthesis at negative 15 over 2. However, with the or equal sign here, I'm forced to put a bracket. Problem number 3. Problem number 3, I have x squared minus 5x plus 6 is less or equal to 0. This type of problem, you have two ways of solving it. One way is, but before you solve it, you got to factor it. So if I factor the left side, I will end up with x minus 3 and x minus 2, less or equal than 0. Well, the zeros or the solutions of this are 3 and 2. Once you find the solution, the first way of solving it is to know that this is a quadratic. If it has 2 and 3 or 3 and 2 as a solution, it seems like the quadratic is something like this, where this point is 2, this point is 3. And since we want it less or equal than 0, it seems like the place that we're concerned about is this bottom place. So I can tell that my solution is from 2 all the way to 3 with bracket around it. That's one way of solving it. The other way of solving it is by using the test point. So I will draw my line that goes from negative infinity to infinity. I will go ahead and plug in my solutions. My solution are 2 and 3. So at this point, I'm making a dark point because I had all equal. I will write a 2 here, and at this point, I will have a 3. Test point means I pick a point anywhere. 0 is my best point, so I will pick the location where I have 0, meaning here. That's where I have 0. If I plug in 0 here, I will have 0 minus 3 times 0 minus 2, which is actually equal to 6. Well, 6 is not less or equal than 0, so this is not portion of my solution. The solution will always alternate. So if this is not a solution, this middle is a solution, and this is not a solution. So the solution remains from 2 all the way to 3. Let's look at problem number 4. Problem number 4 now is a ratio. I have 1 plus x over 1 minus x greater or equal than 1. First thing I will do is move everything to the left side. So I have 1 plus x over 1 minus x minus 1 is greater or equal than 1. To have the common denominator, I'll multiply the top and bottom by 1 minus x. Now on top, I will have 1 plus x minus 1 times 1 minus x over 1 minus x. If you notice, you will end up with 1 plus x minus 1 plus x over 1 minus x. Note that this is still greater or equal than 1. I'm just solving the left side for now. This is equal to 2x over 1 minus x. And remember, it's still greater or equal than 1. At this point, what makes the top equal to 0? One of the critical points is 0, and on the bottom I have a 1. What I will do at this point is use my test point again. That goes from negative infinity to infinity. The first location is where 0 is, and because I have or equal, I will again close it at 0. Now the next one is 1, but 1 is on the bottom of the fraction. So instead of a closed circle, I will write an open one at 1. Open means it's not included, of course. Now let's use the test point. Let's go ahead and plug in. I'll pick a value in between, no, on the right side. Why not? A value here, such as 2. If I pick 2 and I plug in 2, I will have 2 times 2 over 1 minus 2, which is 4 over negative 1, negative 4. Is this greater or equal than 1? Obviously it's not. So your solution is not where the 2 is included. And just as I said previously, it alternates. So if this is not a solution, middle will be, and the last one will not. So your solution will be from 0 to 1 with the bracket. And that will be your solution. All right, let's go ahead and move on to the next problem. Problem number 5. By the way, there's a mistake. I just made a mistake here. I cannot close it at 1 because 1 is not part of the domain. So I will say from 0 to 1 with a parenthesis since it was open at 1. All right, next problem. The next problem, which is problem number 5, is x minus 2 over x minus 1 is less or equal to 0. At this point, I will just go ahead and find the common denominator. That will be x times x minus 1 over x minus 1 minus 2 over x minus 1 less than 0. Well, I will just mess with the left side for now. To mess with the left side, what I will end up with here is x squared minus x minus 2 over x minus 1 less than 0. I will continue up here. Factor the top will give me x minus 2 and x plus 1 over x minus 1 less than 0. Well, once I reach this level, I know that we have 3 critical points. 2 from the top, negative 1 from the top, and 1, which is a critical one, from the bottom. So when I start to do my test point, I will have my line. Of course, the line goes from negative infinity to infinity. This is negative infinity. This is infinity. I will plug in this point starting with negative 1. Negative 1, I will make it a close. Actually, they all open. Negative 1 is open because I don't have the or equal. So I have negative 1. I have 1. And I also have 2. All I need to test is a single point. So let's go ahead and test one point. I would prefer to test the point 0, 0. If I plug in 0 here, I will end up with negative 2. If I plug in 0, I got negative 2 times 1 over negative 1. That will be negative 2 over negative 1, which is 2. Well, 2 is not less than 0. So this position is not a good one. From negative 1 to 1 is not a good solution. So I will scratch it. Now, if this is not a good solution, it means the next one is, the following one is not, and the first one is. So your solution is from negative infinity to negative 1 with a parenthesis, union, and open another parenthesis, 1 till 2 with another parenthesis. Test point will always work for you. All right, let's do number 6. Number 6 is now absolute value. If you remember the absolute value, you will split it in 2. There are 2 cases. The absolute value of x minus 5, you can say x minus 5 is less than. This one you're going to say it can be less than 2, or x minus 5 might be greater than negative 2. Less than is an or, meaning you will end up with two intervals. Or it might be one, we're going to see. So from here, I will add 5 to both sides to get x is less than. By adding 5, I get x is less than 7, or x is greater than. If I move the 5, I'll get 3. So less than 7, greater than 3. You can check this. If this is 3 and this is 7, if it's less than 7, it means that it's going this way. If it's greater than 3, it means that it's going this way. So your solution is from 3 till 7. With now, I can put, because I didn't have or equal, I will put parentheses. That's one way of solving. Now, let's look at the next one. I will first divide by negative 2 on both sides to get absolute value of x minus 5 is, I will have to flip it because I divide by negative greater than negative 1. Well, you're getting an absolute value is bigger than a negative number. This is always true. Because it's always true, the solution always true. The solution is infinity till infinity. It's always true because I'm telling you here that a positive number is bigger than negative 1. All right, number 8. We have 2 left. On number 8, I have absolute value of x minus 5 is less than negative 4. Well, I'm telling you that the positive number is smaller than a negative number. This is not possible. So you will say empty set is your solution or no solution, as you always say. All right. Absolute value of 3x plus 2 is greater or equal than 4. Greater or equal than 4. When it's greater or equal than 4, you will still split it. 3x plus 2 might be greater or equal than 4, or 3x plus 2 might be less or equal than negative 4. I will solve them separately. Subtracting 2 will give me 3x is greater or equal than 2, or 3x is less or equal than, this time will be negative 6. Divide both sides by 3 to get x is greater or equal than 2/3, or x is less or equal than negative 2. If you're not 100% sure about how your solution will look like, always use a line. So I will go ahead and use a line. The first point is the point 2/3. Actually, I start with negative 2, and it's a close point. And I have a point 2/3, which is also a close point. Of course, it goes till infinity, and it starts at negative infinity. I'm saying I want all the x's that are bigger than 2/3. In other words, I'm going this way. The next one, I'm looking for all the x's that are smaller than negative 2. So I'm going this way. Therefore, your solution is from negative infinity to negative 2 with the bracket, union, bracket again, 2/3 till infinity. One thing that you can remember is whenever you have greater or equal, you will have two intervals. Less or equal, you have one interval, usually.